feel free to either shoot a message into the chat or raise your hand. Is a little button there at the bottom. You can unmute yourself since there's only the two of you. You can unmute yourself and try and ask, and I'll stop where I am. That shouldn't be a problem either. Okay. So let me go ahead and share my screen now. Share. That's not what I want. That's what I want. All right. You guys see that okay? Let's see here. Oh, wait. Yeah, that's me. Okay, cool. All right, guys. So we are starting something new this week. We're starting measurements. So instead of talking about cells and microscopes and all that, we're going to move on to a different part of the science. This is actually technically the physics part of science. So we need to understand how to take measurements in science. And this might seem kind of basic, but we're also going to learn about all these different tools that you use to measure in science. Something as basic as a meter stick or a ruler, all the way up to maybe something more complicated, something called vernier calipers. So and everything in between, not only just measuring distance, but volume. So like what we use the graduated cylinders for, you're measuring a volume of either water or any other kind of liquid, to other measurements. So, but we'll get onto that. So first things first, what do we measure? And learning objectives. So understanding how to measure time, temperature, length, area, volume, mass, and density. Now this is all going to be over the course of 2 or 3 weeks. So today we're really going to be focused more on measuring length and area. Mostly is today, okay? And then to understand different instruments and tools we use to take these measurements. That's really important. When it comes to the junior cert, they can ask you questions. They can give you a picture of maybe really basic, maybe a ruler, and ask, what might you measure with this? What units do you use to measure with this? Stuff like that. And again, we'll talk about that all here in a minute, okay? So what are some things that we can measure? What do you guys think? Do you want to type into the chat, or do you want to unmute? What are some things that we can measure?
A brain.
How could you measure a brain, Alan?
I don't know.
Okay, all right. Well, I could see, so Sean says length. So maybe you can measure the length of a brain. So if you measure the length of a brain, you can measure how, like, maybe long. So if I have my head here, right, I can measure how wide it is from point to point, or how long it is from point to point. Yeah. So you can measure the length of it, okay, or the width. Yeah. What else could you measure? Think of like other things, not necessarily what you might use to measure something like length or width, but what is actually literally something you can measure. So a brain.
Size.
Size, yeah. So you can measure someone's height, maybe. What do you measure someone's height in? What unit do you use? How tall are you?
I don't know.
Sean, do you know how tall you are? Feet, yeah, feet. So you can measure in feet, right? Like I am 5 feet and 10 inches tall. You can also use meters. I don't know how many meters I am tall. I'm less than 2, I know that, because I'm from America and I use feet. Yeah, so you guys have come up with all these things that you measure in something called distance, which we in science, we're going to use the metric system or meters, okay? Oops. But so measurement is only useful when it's accurate and it has a unit, right? So if I were to take a big long meter stick and I would just kind of throw it up against Sean and say from across the room, say he looks like he's about 1.5 meters tall, that's not very accurate because I'm standing on the other side of the room, right? And if I were also just to say, I think Sean is 1 tall, that doesn't mean anything, right? He has to be some kind of unit. So that unit would be meters, right? Like Sean also said, you can measure in feet, right? That's another type of unit, okay? So it has to be accurate. You have to be careful in your measurements. You have to look at it very carefully and get a very precise and accurate measurement. and it has to have a unit as well. You can't just give a number. Never, ever in science, ever just give a single number as your answer, right? It has to have a unit. It has to be 1 meter long, or it has to be 55 milliliters full, something like that, okay? Okay, let's keep going. So in science, we use something called SI units. And so what I want you guys to do is in your copies, take down SI units it stands for System International, or the international system. So that's what I want. So take down this first line here. Sean, if you want to pop in a okay when you're done with that, just so I can move on, I'll assume you guys are on the same page. And then if you also want to say, so you have this first bullet point taken down, and then take down this third bullet point. SI units are also easy to convert. That's why we use them. If you both want to pop in, or Alan, if you want to let me know when you're done with that, just so I can move on. I only have about 40 minutes, so got to keep rolling. I'm going to move on in a second if you guys are taking this long. There we go. Thanks, Sean. All right, I'm going to move on. And I'll leave a little bit of time at the end to catch up, Alan. So for example, 1 meter is 100 centimeters. So that's very easy to convert. And we'll talk about how to convert this in a second. But notice it's 100 to 1. 100 to 1. It's not, throwing in random numbers, and like if you're converting like feet to inches, it's not easy 1 to 100. It's 1 inch, or 1 foot is 12 inches, and all these other, it's hard to convert. SI units are usually pretty easy to convert. 1 meter is 1,000 millimeters. So notice that they're always in tens, right? 1 kilometer is 1,000 meters. They're all multiples of 10 of one another. That's always when you're converting these SI units, for the most part, from one to the other, they're always multiples of 10, okay? So on the next page here, so without units, this is what I was talking about when you're in science. Without units, numbers are useless. Whenever you are measuring something in science, it must have measurements. Remember MKS. These are the measurements we're always going to be using in science over the next few years. You're going to be using meters, kilograms, and seconds. That one's pretty straightforward. You're not going to measure time any other way. You're going to measure it in seconds for the most part. You can abbreviate it to minutes, but we're going to really try and use seconds, okay? So you're always going to use meters, not feet or anything like that. Always going to use kilograms, no pounds or stone. Always kilograms and seconds, okay? So moving on. So real quick, name these measuring instruments. What is this one here that I'm hovering over?
A measuring tape.
Very good, Alan. It's a measuring tape. Anybody know what? Either of you know what this is? I'm gonna take that as a no. Alan, you've unmuted. Do you know? No. It's an opsimeter. Opsometer. So you use these. It's actually, it fits in your hand kind of like this. So you kind of run it along a piece of paper, and you use it for curved lines, like a map. If you wanted to measure the length of a line on a map, maybe. Anybody seen this before? Either of you guys seen this? You might have seen it in PE. It is called a trundle wheel. So this is actually probably about up to my hip, maybe a little higher. And you kind of you wheel it along the ground, and you use it for longer distances. Maybe you're measuring the length of a football pitch or a running track, or just, like the length of a parking lot from one end to the other. You can measure the length of that. What's this? Name it real quick.
Ruler.
Ruler. Good job, Sean. Ruler. Anybody know what this is? No. That is a caliper. It's specifically a vernier caliper, but this is for circular objects, and we're going to talk about that in a second here. And don't worry about taking anything down because we're going to go talk about each of these individually here. But so we said, what units do we use to measure length? We said meters. That's always going to be abbreviated with the little m. So if you're writing an answer in your copy and I asked you the question, what is the length of your pencil? And you took out a little ruler, you measure the length of your pencil, you would have to give me the length of it in meters or centimeters or millimeters. And then you would always give it the little abbreviation at the m or at the end, which if you're talking about meters is m. If you're converting it to centimeters or millimeters, it's the little mm or cm. There we go. Okay. But so this is what I'm talking about. So you have to be able to convert from meters to kilometers and from centimeters to meters to kilometers. And we use these things called prefixes. So when you're measuring the basic units like meters, grams, and liters, we have to use prefixes to say how many there are of something. So before I move on, let me think. So if you guys can take down, no, you know what, don't worry about taking anything down yet. We'll do that on the next slide. Yeah, I think, yeah. So there's a lot going on here, right? What this is, if you look over here, it gives you the prefix. So it says kilo. So a kilometer is 1,000 meters, right? A hectometer, which you don't really see very much, but is 100 meters, right? Decameter, 10 meters. And then you have your 1, and then you start getting smaller and smaller and smaller. What I would like you guys to do is, I should have done this, so I'm actually going to do, let's see here. I'm going to go ahead and, if you guys can take down real quick, where's my shape? There we go, perfect. So I'm going to put a little little circle, maybe tiny circle. There we go. So wherever I put a circle, can you copy? Oops. Can you copy that line down into your copies? So I have kilo, deci. Oh, sorry. Thanks. I will fix that in a minute. So okay. So perfect. Window, right? I think I have it there. Perfect. Okay, there we go. So what you guys need to do is, you see where I have these little blue circles. You need a chart that is 1, 2, 3, 4 rows down and 1, 2, 3, 4 rows across, okay? And take down kilo, that's the prefix, the symbol, what it multiplies by, and then something called the exponent form, which is what I'll talk about in a second, okay? So go ahead and take that down in your copies real quick. Those are probably the most popular ones you guys will see in science right now. It'll be best if you remember those for now. The rest of them, like I've never seen exa really used in normal it's such a big number. Like if you had 1 exameter, that's 1 times 10 to the 18th power. So 1 times, is that a trillion? So this is 1,000, 100,000, million, billion, trillion. Oh, so it's even bigger than a trillion. Like tera is a trillion. So I can't even I can't even fathom how big an exameter is. About 20 minutes left there. Let's try and get through as much of this as I can. Don't want to rush it either. if Sean or Alan, you want to shoot finished or done into the chat, then whenever you're ready. Great. Okay. Thanks, Sean. So there, over here, it says the exponent form is how many zeros there are before, if it's a minus number, so down here, or after if it's a positive. So for example, I'll skip down to here. If you have something like 2 kilometers, so that's one of the ones you took down, 2 kilometers, you have to, all it says is you take whatever the prefix stands for. So we know that kilo stands for 1,000. Multiply it by whatever number you have. So if you have 2 kilometers, you have 2 of them, you multiply that by the prefix kilo, which means 1,000. So 2 times 1,000 equals 2,000 meters. Pretty straightforward. Same thing in liters. So if you have 5 milliliters, that is the number 5. So if you have 5 of them, multiplied by the prefix milli. So if we go over to our chart here, milli equals this 0.001. Multiply that out, and that gives you 0.005 liters, okay? The exponent form just tells you how many zeros there are before the multiplier. So for example, if you go down, if you're told to multiply it by 10 times, or 10 to the negative 15th power, that's what we call this. It tells you that you have to multiply it by the number 1 with 15 zeros before it. So if you see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So whatever this is 1 and then however many zeros before it. And then you just multiply that by. So if you had 11 picometers, right? So if you're measuring something super, super small, like a virus or a bacteria or a cell, you might measure that in picometers. So if it was 9 picometers across, you would take the number 9 and then multiply it by this number here, 9 times 0.0000000000001. Does that make sense? You guys okay? I'll take your silence as a tacit agreement that you're okay. Okay. If you have any questions, just stop me, please. That's all this is. And so this is pretty important when it comes to taking measurements. So if you don't want to, if you're measuring a really, really large number, you're not going to measure the distance from where I am in Kildare to Dublin in meters, and it make much sense, right? It'd be a lot of meters. Or even, so what you might then do is shorten that to kilometers, right? Because if we know that 1,000 meters is 1 kilometer, right? I'm not going to, and if I'm 30 kilometers from from Ballymun, that would be 30 times 1,000, so 30,000 meters, or I could just say 30 kilometers. It's easier to use the smaller numbers, okay? Okay, oops, there we go. So just something real quick when it comes to reading, maybe reading a ruler, we have something called parallax error. So when you're taking measurements in class or even at home, you need to measure, like maybe you need to measure the length of a table because you need to replace it or something. You need to make sure that when you're looking at what you're measuring, you're looking at it straight on. Don't look at it from the side because it can cause something called parallax error. Don't worry about taking this down for now. But just make sure that whenever you're looking at a ruler, you're looking at it straight on, not looking at it from an angle, okay? Okay, so the different tools that we're going to use. I have enough time here. So we have something called simple calipers. You might have seen these before, but all they're used is to measure the diameter of maybe a pipe or a beaker, anything that's kind of round. And the diameter, so what I want you guys to do is in your copy, take down this term here on the left, diameter, length of a line that goes through the center of a circle. You might already know that from maths, but if not, now you know. And what calipers do, both simple and the next one I'll talk about, is they measure the diameter. You can either measure the external diameter, which is how far on the outside is to the other outside, or the internal diameter, the inside to the other part of the inside. The reason these might be different is if this glass is really thick, you know, if you have glass that's this thick rather than maybe really small like this thick, the difference between the inside, so notice, if you're looking at me, notice how far apart the insides are, right? So if my head's on the inside of this glass and this is how thick the glass is, notice how close the insides are, where my thumbs are, but notice how far away the outsides are. There's a big difference, right? So if you're measuring the outsides, my pointer finger's out here, it's going to be a much bigger distance than where my thumbs are right here. So what you do then? So once you get this taken down, what you're supposed to do? Make sure that if you're using these calipers, that you're measuring the diameter, right? So it needs to go through roughly the center of whatever you're measuring, the line from here to here, not out here and not out here. That's the green line you're measuring. And what you'll do is you'll take this line, you'll take the calipers, so you'll leave the calipers where they are, you'll kind of take them off, and then you'll put them up to a ruler and measure the distance of the calipers, how far they're open. And that's how big the diameter is of the object that you're measuring, right? Same here. You would leave this open, you'd leave these the way they are, and then stick it onto the ruler right there and measure how far open they are. You could do the same with a pair of scissors, maybe. You know, you open up a pair of scissors, see how far they are, how far open they are, and then just put that down to a ruler. Easy peasy, right? Okay. Let's go on to the next one. So yeah, the jaw width of the calipers is measured with a ruler. So that's the jaw width right there, or right there. All right, so veneer calipers. These are a bit different. They're a bit more complicated. But what they are is they're more accurate. So they actually have a built-in ruler onto where what you're using. And they're used to measure small lengths or thicknesses. So if you wanted to measure maybe just simply the thickness of a book, right? So if I have my science book sitting right here. So if I wanted to measure the thickness of this book, I could take my veneer calipers and kind of place them onto here, and then pull them off, and then you'd have to know how to use this. So you have two different parts of this. You have the main scale, which is the part on the back of it that looks like a normal ruler, and then you have the vernier scale, which is this kind of bit tagged onto the front of it here. But what I want you guys to do first, before I move on, is maybe make a subheading, veneer calipers, and then take down these two points here. More accurate than simple calipers, used to measure small lengths or thicknesses. Take that down real quick. And if Sean, you can shoot a done in when you're done. We only have about 10 minutes left, so I want to keep moving. Give me another 15 seconds. Yeah, there we go. Great. Okay, so so this is how to use them. There's a lot of words here. don't worry about reading through this paragraph. I want to leave that there just in case anyone misses this or you want to go back over it, because it's a very good step-by-step. But all you have to do, you insert the object that you're measuring, right? So maybe it's this little plastic ball, or maybe it's the book that I used as an example. And this slides this out a little ways, right? You then look, this is what you're looking at then. So if this is zoomed in right here, right into this little box here, okay? And what you do is, if you notice, like this 0 right here is right here. That is how wide, how thick this object is. It's 3 and 1, 2, and a bit centimeters, right? Because we're measuring in centimeters. We know that from this little cm right here. So we have 3 centimeters plus 1, 2, and then a bit. That's the 0 line. What you then do is, you know, it's somewhere between 3 centimeters and 3.2 and 3.3. You then measure it on the vernier scale. That's these little indicators down here on the top. You measure it then. So you have 3 plus 1, 2, 3, 4, 5, going out to the one that's lined up the most, right? So if it was, if this one was lined up perfectly here, it'd be 1, 2, 3. But we find the one that's lined up the most perfectly with the main scale, and that's where you count to. So it's 3, because it's somewhere between 3 and 4, 0.12, somewhere between 3.2 and 3.3, 3.1, 2, 3, 4, 5, 6, right? So it's so it's less than 3.3, more than 3.2, 3.26, okay? If you were to tell me it's 3.2, that's pretty good. Or 3.3, somewhere in there, that'd be pretty good. But then you can use the vernier scale to get even more accurate, okay? Okay. Yeah, so therefore the diameter of the ball is 3.26 centimeters. That's how long the diameter is, okay? Okay, so the opsimeter, I'm just gonna show you this real quick video. Even if you guys can't hear it, but you should be able to. So notice that she started at a point up here, and then there's a little roller on the bottom here, and she's just rolling that along the lines on the paper. And you can see the little gauge here moving as she's rolling along. So all that is doing, and I'll stop that there, is as the roller on the bottom is rolling, it's tracking how far she's moved, right? Because it's pretty hard to measure a curved line with a ruler. You can't really do it because there's so many curves, and as you go up and then down and up, you can't measure all those individual lines, right? So you have to use an opsimeter to do that. So again, lots of words here. This is just how to use it, because in our class we'll have one that kind of looks more like this. It's really, really basic. It's just a wheel on an axle that attached to like a handle. And I'll show you guys more of how to use this in class. But basically, you roll it until the point sticks. You reset it. This is the point right here, or the point down here. And then you roll it again till the point sticks, and that's how you use it. But just if you can write down in your copies, opsimeters are used to measure the length of curved lines. Have that down in your copies. I'll show you guys how to use those in class. And for anybody that's watching this video after the class, just skip through these empty zones of while these two are working. No need to sit in silence. So ops meters are used to measure the length of curved lines. A lot of the time they're used for maps. So, because normally at the bottom of a map, you'll have a little key that tells you how far on the map a certain distance is. Yeah. So if you're trying to track the difference.
I'm finished.
Thanks, Alan. If you're trying to measure the difference between on this map here, Ross Cray and Thurles, maybe it's from here to here on the map, it's 4 centimeters. Then at the bottom, it'll tell you that 4 centimeters means 30 kilometers in real life. Something like that. Okay? All right. So let's do one more then. So trundle wheel, we talked about that. That's really easy. A tool for getting a rough measure of distance. Make sure the counter is set to 0. So usually these trundle wheels will have something that looks like this on the end of them. Make sure it's set to start at the top here. And then you just walk and walk and walk. And usually it clicks. And every click is maybe 10 meters. And you just keep track of that in your head. Take this down, usually used to measure football pitches or athletic tracks. So longer distances. You wouldn't obviously use an opsimeter. Oh my God, I can't remember the name of it now. Opsimeter, yeah. Opsimeters to measure really long distances because they're tiny, right? It would take you forever to measure that distance. So you use a trundle wheel, which is basically a big opsimeter. And you measure that length with that. Maybe you want to measure the length of a driveway or the width of a street or something like that. You would use this for that. Sometimes there's digital ones that have a little counter that you can just look at. It counts for you as this rolls along. Those are really easy to use. But usually used to measure football pitches or athletic tracks. Make sure you remember what they look like. Let's see here. Good. Good. Good, 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 good. All right. I'm going to leave that there today because we only have 2 minutes and I can't get through the rest of this. So what I'm going to do then for finishing today's work and for everyone else who wasn't here is you're going to have a few practice questions, and then you're going to fill out what you can in this chart here. There's a few of these, and I don't want to move on, or else I'll show you the answer. Oh, here, actually, I'll back out. So I'll present something real quick to you guys. Nope. Yeah, that works. Okay. Okay, so what you guys will do, and I'll put this all up on Google Classroom here in a minute, so don't worry about writing anything down. For the last bit, so between now and next Monday, there's a few practice questions here. So what would you use to measure the length of a driveway, the height of a student, the diameter of a ball? Write all those down in your copy. What units would be best for measuring the following? So we know that we measure length in meters, but you might not use a meter to measure the length of a pen because that'd be, meter sticks are probably really long and a pen is so short. So you probably have to use a different kind of unit. So what I mean is like maybe a centimeter or a decimeter or a millimeter, stuff like that, right? Those are all different units. Same thing with distance from Dublin to Limerick. Probably not going to use meters because they're so short, and you're definitely not going to use centimeters because those are even shorter. You're going to have way too many, and those numbers are going to mean much. And then what you guys need to do is, to the best of your ability, put these 3 charts into your copies. They don't have to be 3 different charts. It's just I couldn't fit them all onto one slide. So copy these down into your copies and then give me the name of it. You should know all of them at this point because either you've used them in class or I've talked about them today. Give them name, what they measure. So for example, I'll give you an easy one. Obviously, this is a ruler. This is a ruler. It measures distance. I don't want you to say meters because that's what unit it measures, right? So give me the name of it, a ruler, what it measures distance, and what it measures distance in meters, okay? That's the SI unit. Any questions before I call it? I'm running over on time. Thanks so much, guys, for being here. Try and do it again next week. Try again on Wednesday, since I had at least 2 of you. All right, guys, I'm going to stop recording.